Under the emergency lights, the control room at NASA suddenly flashed red. An alert, unlike any other, had just been activated. The system, designed to track celestial hazards, had not only signaled a random rock, but also marked an object on a dangerous intercept trajectory. That object was 3I Atlas, an interstellar object that was hurtling towards Earth's moon. Observations confirmed an extreme scenario. NASA declared a Level 2 emergency, a designation reserved for real threats that could collide with a celestial body. Asteroid tracking sources indicate that similar alerts only occur when the probability, while small, translates into real danger. At this point, scientists are faced with a chilling question that if 3I Atlas impacts the moon, what will happen next to the moon's surface to the satellites orbiting the Earth? Even to us on Earth, everything that we once thought was fixed and secure suddenly becomes fragile, because at that moment, humanity's biggest fear is no longer the distant stars, but the silent thing that is accelerating straight towards our satellite. Stay tuned, because what happens next will blow your mind. If you are fascinated by the mystery of 3I Atlas and want to see more amazing cosmic stories, hit the like button and let the universe know that you are watching. Every click helps. Keep the search for the unknown alive. Comment below and let me know where you are watching this video. I want to see which corners of the world are witnessing this with me. Preliminary data from NASA confirmed the object codenamed 3A Atlas, the third interstellar visitor ever recorded by humans after Oumuamua in 2017 and 2I at Borisov in 2019. But unlike previous harmless travelers, 3I Atlas did not quietly glide through the solar system, but instead slammed into the moon's gravitational field at a speed of more than 150 miles per hour, enough to cross the Earth's moon distance in just a few hours. Within minutes, NASA's impact simulations were running continuously each update, raising the alarm level. The results showed a potential impact crater 1,218 miles wide and an explosion bright enough to be seen with the naked eye from the Washington sky. The Planetary Defense Coordination Office immediately declared a state of emergency. NASA, ESA, and JAXA have activated 24-hour synchronized monitoring, tracking every orbital wobble, every tiny change in light intensity, all recorded in real time. As if awaiting an unprecedented event, the possibility that humanity is about to witness the first collision between an interstellar object and Earth's natural satellite has turned what was once a purely academic study into a global obsession. Harvard astrophysicist Avi Loeb, who has challenged conventional theories about Oumuamua, has begun examining 3 Atlas with unusual caution. His team has noted that the object's motion is unusually stable, with a precision that exceeds that of any known natural comet, while Loeb has not made any claims. His previous studies have raised the possibility that not all interstellar travelers are mindless. Meanwhile, at NASA's Jet Propulsion Laboratory, experts were faced with an inexplicable paradox. 3 Atlas's flight path was largely unaffected by solar wind or radiation pressure, acting as if by an invisible guidance mechanism. The debate was intensifying. Was this a once-in-a-generation scientific opportunity, or a harbinger of a cosmic catastrophe that humanity would be powerless to prevent? If the moon were to collide, tidal models predicted small but measurable changes in Earth's rotational stability that would alter tidal rhythms and orbital resonances, not destroying the moon, but enough to shake the delicate balance that has nurtured life for billions of years. As telescopes around the world focused on the approaching light, an eerie silence fell over mission control. No rockets to launch, no means to intervene. All that remains is to watch, wait, and count the seconds in a countdown. Not to prevent collision, but to witness what the universe will reveal next as new readings trickle back to NASA mission control. 3I Atlas's orbit began to warp in unexpected ways. The interstellar object was no longer on a stable arc, but was now curving silently southward, tilting toward the lower hemisphere of the moon. The drift was initially small, but each update narrowed the margin of safety, revealing a drift that was clearly trending and not random. Simulations showed that if it drifted less than a degree 3I Atlas would fall into the moon's gravity window, where the moon could lock its orbit and drag it down to the surface at speeds exceeding sinuenta, 0 miles an hour. Escape would be nearly impossible. If this trend continued, a collision could occur in less than 3 weeks. At the GH Space Flight Center, thousands of Monte Carlo simulations showed a decreasing probability of safety as a collision unfolded in real time. Observatories around the world have confirmed that the object is hurtling toward the moon's south pole near Shackleton Crater, where ancient ice deposits are suspected. A collision there could send up a column of dust hundreds of miles high, enough to change the moon's color and brightness for months. Harvard astrophysicist Avi's team continues to study 3 Atlas's unusual movements. Unlike typical comets, it remains stable and adjusts its course in response to weak symmetrical flares of gas detected by USA's solar probe. This has sparked debate at the Jet Propulsion Laboratory, where some experts believe it is simply a natural outgang, while others argue that the precision of the adjustments fits perfectly within gravitational windows like a response to a navigational signal. By the end of the week, the impact corridor had narrowed to less than 200 miles, while the smallest uncertainty ever recorded for an interstellar object. One engineer claims that if 3I Atlas were to shift just 1 degree, humanity would witness the first interstellar collision in history. The question haunting scientists now is whether it is all due to gravity or whether there is an agent controlling the orbit at Goddard. Energy analyses describe a terrifying scenario. The collision could release energy equivalent to hundreds of megatons of TNT, 10 times more powerful than the Tsar Bomba, without an atmosphere to absorb the impact. All the energy would slam into the surface of the moon, creating seismic waves that spread into the core. A crater nearly 20 meters across would form, blasting billions of tons of dust into space, creating a halo that would circle the moon for hours or days. The light from the explosion is predicted to be strong enough to be seen with a naked eye from any continent, even during the day. While the expected spectacle was spectacular, the Planetary Defense Coordination Office warned that the dust cloud could alter the moon's reflectivity for months or years, disrupting the tides and Earth's rotation. Oceanographers predicted stronger coastal waves, while climate scientists worried that the reduced moonlight would affect nighttime ecosystems and atmospheric cycles that have existed for millennia. Still, social media was buzzing with the phrase "second moon," along with a series of simulated images of the sky glowing after the impact. While the public was captivated by the spectacular prospect, engineers in Pasadena were glued to the ever-increasing probability curve. A scientist reminded the control team that the light from the impact would take 13 seconds to reach Earth, and when it did, it would be all over. As the countdown approached 0, a hush fell across observatories around the world. For the first time, humanity is about to see the universe in motion, not as an abstract concept, but as a real force capable of shaking the heavens and the world beneath its feet. As the potential impact point approaches, scientists are beginning to worry that the greatest danger lies not in what can be observed, but in the unseen effects. NASA's seismic resonance models show that if 3I Atlas were to strike the moon, the shock waves could cause the entire satellite to vibrate for hours, creating a moon chime effect. The phenomenon was first observed in 1969 when the Apollo 12 rocket stage crashed into the moon, causing seismometers to record vibrations that lasted nearly an hour. This time, experts warned the impact could be thousands of times more powerful. The Apollo seismic network, still operational thanks to modern telemetry, will be a vital source of data that could reveal structures deep within the moon that probes and radar have never been able to see. However, if the impact occurred on the opposite side of Earth, some researchers warn of the possibility of weak seismic resonances that could be transmitted back to our planet. Even small changes in the moon's mass distribution could affect its rotation and tidal cycles. The Goddard Institute for Space Studies confirms that in theory, this chain reaction could have long-lasting effects, changing ocean tides, adjusting the length of a day, or disrupting the orbital synchronization that keeps Earth's axis stable. Even the smallest changes in the moon's behavior could affect the timing of high tides and the migration patterns of marine life. According to NASA, climatologists calculate that a change in Earth's tilt of just 0.1 could distort seasonal rainfall patterns while lengthening the day by a few seconds, could alter atmospheric currents. The stability of the moon, a cornerstone of life's natural rhythms, could be disrupted. The atmosphere in the command center became tense. The question was no longer how much the moon could withstand, but what Earth could endure if its only satellite were thrown off balance. As one geophysicist noted in a late-night report, we spent centuries watching the moon's light. Now we're about to hear its internal pulses that could be reverberating back to Earth. 3. Atlas's approach forces NASA and other major space agencies to confront an unpalatable reality. Our planetary defense system still has such a large blind spot that an interstellar object could pass through our solar system almost unnoticed. The Atlas network, designed to detect asteroids in our own solar system, only detected 3 Atlas after it had already crossed the boundary of our neighborhood and entered our solar system. Too late to intervene it. Leaked internal reports from the Planetary Defense Coordination Office show that the current warning system relies entirely on predictable orbits, which is no match for superfast interstellar objects. 3. Atlas has fallen through a loophole that humanity never thought possible. As international media exploded, hearings and debates broke out. ESA argued that the responsibility for monitoring could not be left to one country. JAXA called for a global early warning alliance, and China quietly expanded its own observation program. Yet the countdown continued. In Geneva, during an emergency session of the United Nations, a Brazilian delegate raised a question that silenced the entire hall. If the target was not the moon, but the Earth, would we have noticed in time? This question quickly became the focus of every news report. Meanwhile, NASA's simulation team calculated a scenario where the orbit deviated just 1% toward Earth. The impact energy was equivalent to 100,000 nuclear warheads, enough to burn up the upper atmosphere, create a cloud of debris covering the globe, greatly reducing sunlight, and causing the weather to fall into chaos. Scientists compare it to the Chicxulub event that wiped out the dinosaurs, but this time humans knew it and were helpless. In scientific circles, the message spread quickly. 3. Atlas was not only a rare phenomenon, but also a warning about the fragility of humanity's understanding of the universe. Plans for a new generation of wide-field observation sensors have been discussed. But according to NASA's roadmap, it will take years to develop and deploy. For now, Earth is still dependent on the existing warning network, and all scientists can do is watch the data continue to roll in on screens. One researcher summed up the situation in a short but chilling sentence: "We are learning the hardest lesson. The only way we can, which is by watching it happen in silence, cope." As the 3 Atlas moment approached, the world was split into 2 opposing camps. One camp believed this was the greatest scientific opportunity in human history, a unique window to directly observe a planetary-scale collision. The other warned that this could be the precursor to a cosmic catastrophe, an event humanity was unprepared for. At observatories from Hawaii to Chile to the Canary Islands, telescopes were running full-time, transmitting terabytes of data every hour. Every spectral variation, every unusual flash of light was analyzed and archived with the hope that decades from now, humanity would have enough data to understand what really drives the behavior of an interstellar object. In the moments before impact inside NASA, the divide was becoming more pronounced. Astrophysicists saw this as an unprecedented opportunity. They argue that no simulation, no matter how sophisticated, can replace the direct observation of a lunar-scale impact. We've been modeling these events for decades and have never seen them. One researcher told Nature, "This moment could rewrite our entire understanding of impact physics." Quote, "On the other side, systems engineers and planetary defense experts warn that the risks are being underestimated. Their models show that even a slight offset could alter the moon's orbital stability fluctuations, or create a giant dust storm that could potentially reduce sunlight reaching Earth." One tense internal meeting. A senior NASA analyst said bluntly, "We're playing the role of observational scientists, but we're standing right under the hammer." As the clock ticks down, the scientific debate turns into a question of survival, and the world is forced to wait and see whether 3 Atlas will be a turning point in knowledge or a final cosmic warning to humanity. Amid rising tensions, the private sector has entered the race. SpaceX and Blue Origin have received urgent requests from NASA and ESA to prepare robotic probes capable of reaching the lunar South Pole before the expected impact. The goal is to observe directly from the surface, gathering data that satellites cannot provide. However, the plan quickly raises questions. Will the launch disrupt the debris' trajectory? And will the probes arrive before the event occurs? On social media, the debate is widespread. Some people call for the use of boosters, even nuclear measures, to divert 3I Atlas and the DART model. Many scientists objected, arguing that any intervention could ruin the most precious natural experiment in history. Religious and philosophical debates also arose, turning 3I Atlas into a symbol of fear and faith. At the panel discussion, a planetary scientist remarked, "The universe is conducting its own experiment, and this time we are both spectators and subjects." Quote, "As 3I Atlas's green glow grew clearer in lunar orbit, the world held its breath. Some prayed, others checked their equipment, and then something unusual happened. NASA abruptly stopped all updates. The live data website froze. Press conferences were postponed without explanation, leaving the world bewildered by the unusual silence. Independent astronomers immediately stepped in. Comparing their data with archives, they discovered that 3 Atlas had unusual brightness fluctuations near the lunar South Pole. Notably, the object appeared to periodically slow down and then speed up a behavior that is the exact opposite of a natural comet. Inside the Jet Propulsion Laboratory, insiders described a clear unease mood. An anonymous engineer told the Washington Post that the energy spikes observed could not be explained by gravity. The object, he said, was adjusting its velocity. If so, 3I Atlas no longer looked like an interstellar rock, but rather like a ship actively navigating its own course. According to leaked minutes from the Aerospace Intelligence Agency meeting, several senior scientists reportedly briefed the Pentagon and the White House privately. The discussion centered on whether to classify the event as a national security anomaly. Some speculated that releasing the full data could cause panic. Others believed that the silence would only fuel the conspiracy theories circulating online, and they were right. On Reddit, X, and TikTok, amateur astronomers posted real-time observations that suggested the light fluctuations were too precise to be random. Theories proliferated as 3 Atlas, a probe, a piece of alien technology, or something responding to human observation itself. And a small but vocal group of scientists began to question NASA's restraint. Harvard's Avi told The Hill, "If there's even a 1% chance this object isn't natural, we have an obligation to study it openly. Hiding data doesn't protect anyone. It delays understanding." Meanwhile, European and Japanese observatories reported similar anomalies, but didn't publicly confirm them, switching to encrypted internal channels for public updates and then going silent. Then on the night of October 28th, the day before the expected collision, the Lunar Reconnaissance Orbiter sent back inexplicable images, showing a faint pulsating light trailing behind 3I Atlas, expanding and contracting as if it were breathing. Within hours, the image had disappeared from NASA's servers, as reporters asked why officials were calling it a data compression error, but few believed it. As the world stared at the dark side of the moon, waiting for the moment of truth, one question rang louder than any news story. Was NASA tracking a falling comet, or hiding something humanity would never see? As the moment drew near, the world held its breath. Billions of people looking up into the night sky for a flash. Yolt. Anything to prove that what they feared or hoped was real. For a few endless seconds, the moon hung in silence, pale and motionless, as if the universe itself was waiting to decide what would happen next. No one knew whether they were about to witness a catastrophe or a revelation. Some expected a blinding explosion. Others believed they would see nothing at all, that the real impact would be quietly played out in data and memory. But in that collective silence, something changed humanity with all its instruments and equations. Finding itself humbled once again by the unknown of the universe, the moon became a mirror reflecting not only the light of the sun, but also our deepest human fear that we can observe the universe unfold, but can never control it. The story of 3 Atlas is no longer just about science or danger. but about a perspective of awareness of how small and temporary our control really is. Whether it collides or passes, the lesson is the same. 3 Atlas reminds us that the sky we think we know can change in an instant, and that knowledge itself is on the brink of fear. Perhaps the universe isn't bringing destruction, but a warning, or maybe an invitation to look closer next time. So, do you think 3 Atlas is a natural experiment from the universe, or something sent here to see us? Leave your thoughts below and subscribe, because what happens next could change the way we see the sky forever. See you soon.